So in the last lecture, we ended with the electromagnetic waves, right, guys?
Yes, sir.
So today we will start. The last time we defined a few terms, and those terms were, there was this lambda. We call this lambda as what? Wavelength. Okay, this is wavelength, and its units are meter in length. Okay, then we had this unit, this term which is mu. It is what? It is the frequency. It is the frequency, and its unit is time inverse or second inverse, and this second inverse can also be written as hertz. Okay, it will be what? It is for only for frequency. This hertz is only for frequency. Okay, so for example, if you are writing speed of something and it is 10 meter per second, so you cannot write 10 meter hertz. Okay, this will be wrong because hertz is specific for frequency, and its unit is second inverse, and 1 second inverse is equal to what? Is equal to hertz. Then after frequency, we formulated a expression or relationship, that is lambda into mu is equal to c. Is that right? Now you will be given, you will be c. For c, it is a constant. C is equal to how much? C is equal to 3 into 10 to the power 8 meter per second. C is a constant. Now you will be given either the wavelength or the frequency, and you will be asked to calculate either one of those. Okay, is that fine, everyone?
Yes, sir.
Now also define one more item here, one more term, which is known as wave number. So wave number has a sign which is mu bar. Okay, it is what? It is a mu, and there is a bar above it. It is defined as the number of wavelength per unit length. Okay, per unit length. You got it? Number of wavelengths per unit length. For example, if you are taking a unit length as centimeter, so for example, here you have, here is 1 centimeter. Okay, so how much will be 1 lambda? If we start from this point, so we will go till this is 1 lambda, because where we started, we are again at that point. Now then we can say this is another lambda. Okay, but we are just reaching here. So this distance, the red one, this is 1 lambda. Okay, now from here to here we have 3 by 4 lambdas, correct? So the wave number for this particular wave will be equal to lambda plus 3 by 4 lambda per centimeter. Okay, so this will be how much? This is 3 by 4 plus 1 lambda will be equal to how much? 4 plus 3 divided by 4, 7 by 4 lambda per centimeter. Okay, so this will be 7 by 4 centimeter inverse. Wave number will be equal to 7 by 4 centimeter inverse. Okay, so please write this wave number. Okay, have you written? Has everyone written about wave number?
Yes, sir.
Yes, sir.
Okay, now write a question. Calculate.
Sir, I got
the wave.
disconnected.
Could you show the previous slide?
Yes, sure.
Yeah, okay, sir, done.
Calculate the wavelength of the frequency at which All India Radio, what is AIR? All India Radio broadcast its program Rehab Khalik casts its program which is 1368 kilohertz. So how will we do this problem? This problem is easy. You have been given what? You have been given the frequency. You have to calculate the wavelength. So what is the relation here? The relation here is C is equal to lambda into mu. So you have got the mu here and you have to find the lambda. So lambda will be equal to mu by C. What is mu? Mu is equal to 1368 and see here it is kilohertz, right? It is kilohertz. So you will write into 10 to the power 3 and hertz is what? Nothing but second inverse. Correct? Is everyone with me till here?
Yes, sir.
But guys, I did a mistake. You should have told me lambda will be equal to C upon mu. Correct? This is equal to 3 into 10 to the power 8 meter second inverse divided by 1368 into 10 to the power 3 second inverse. Now what we can do, we can cancel this second inverse and the second inverse. Then you can calculate this, okay? Start calculating this. First of all, see the very basic first thing that you will do is always eliminate. Okay, so always eliminate. The first thing that you will eliminate is units. So you know the units will be in meters. So first you will confirm that, okay, fine. Whatever answer I'm going to get, the unit is right. Second, you will eliminate the powers of 10. Okay. And after that, simplify. Okay, so this is a mistake proof method. Okay, Rehab, are you here for 11th standard atomic structure?
Yes, sir.
Okay, fine. So have this is your first lecture, right?
Yeah.
Okay. Just follow along. Okay. Whatever we are learning, I will give you a heads up. So we are doing a question. You entered the class at a very precise time, I guess.
Sorry, sir.
You don't have to be sorry. You are in which school, by the way?
ISR.
Riyadh
Yes.
International Indian School.
Yes.
Heba is your classmate? You don't know Heba?
Hiba Sajid?
I don't know which Heba is this.
Yes, sir.
हाँ, आप लोग दोनों बात कर लीजिए देखिए हंस रहे हैं बताइए Where are you from, Rehab?
I live in Riyadh, but I'm from UP.
Yeah, अच्छा यूपी में कहाँ?
Lucknow.
लखनऊ। अच्छा, तब तो आप नाम नहीं इसमें बताते होंगे, राइट?
Sorry.
सर नहीं, आप रियाज में रहे, सॉरी, यू आर नॉट फ्रॉम लखनऊ देन।
Yeah, NRI.
So, are you guys friends, Hiba and Rehab, or
Yes.
you just?
Yeah.
अच्छा, लेकिन बिना बताए लर्निवियो ज्वाइन कर लिया है ना? You will be complaining now. Yes, Hiba, you didn't tell anyone. Hiba is silent. Hiba is like अकेले स्कोर करना है सर, आप क्या बात कर रहे हैं? Okay, guys, it's good. Anyone with the
Sir.
answer, please?
Sir,
हाँ.
actually, she is so happy that she is smiling and laughing here.
So she is happy that Rehab has joined.
I don't know what happiness she have, either the answer or afraid.
She has got the answer. Yes, Hiba. Send me the answer then. Yes, guys. Khalid Salman used to be very fast. Now what happened?
Yes, sir, I got stuck in the calculation.
Same one.
She got stuck in the calculation, guys. So Hiba, you are not so late, I guess. You can see these guys. Hiba, okay, Rehab, sorry. Rehab, can you calculate this? New student, please. थोड़ा आपका वर्चस्व बढ़ जाएगा क्लास में. So this 10 to the power 3, it will go up and it will be 10 to the power 8 into 10 to the power minus 3. Whatever we will get, it will be in meter. This will be 3 by 1368 into. This will be how much? 10 to the power 8 minus 3. 8 minus 3, which is equal to 3 upon 1368 into 10 to the power 5. Okay. So Khalid has given the answer. I was thinking Rehab will give the answer. Rehab, you pronounce your name like this also, like this only, or is this Rehab? How do you
It's
pronounce it?
rehab. Rehab.
Rehab. Okay, okay. Thank you. Okay. 0.002. Okay, yeah. So you can write that that answer is correct. You will get 2.1 into 10 to the power minus 3. That's 3 by 1368 into 10 to the power of 5. This will be equal to how much? 2.1 into 10 to the power 2. Right? This will be in what? Meters. This will be in meters. Okay. So can you think how large this wavelength is? It is what? It is almost, I can say, 210 meters. Correct, guys? It's very large, na? 210 meters. So this is radio waves. Now, how do I know this is radio wave? I have not memorized the whole energy level and the wavelengths. I saw that this is all India radio, so obviously it will be a radio wave. You guys got this? Can I move to the next question? Can I move to the next question? Yes, no.
Yes, sir.
Yes, sir.
Okay, by the way, for let me introduce a few things for Rehab. Okay, so Rehab, we are learning about atomic structure, but now we are in a state where we are learning about some waves. So these are the waves, and there are few terms that you have to know about these. So we have found this now. Okay, like, can you see this wave, Rehab? This blue wave?
Yes, sir.
Okay. So there are few things that we want to define with define about this wave. So the distance between two maximas or two minimas or any two same points. Okay. So this point and this point is same. As this red point and this here, this black point is same. Okay. Don't think that this black point and this black point is same. They are not same because, as you can see, At this black point, at point 1, we are going upwards. At point 2, we are going downwards. So these are not same. But at point 3, we are going upwards again. Similarly, this point, if I say this point is A and this point is B, these points are very, very same because in both of the points we are going down. Here also we are going down. So these points are known as what? Lambda. And what is lambda? Lambda is wavelength. This is the length between two maximas. Just remember this. This is the length between two maximas or two minimas. Is that clear? For Rehab?
Yes, sir.
Okay. Distance between two maxima. Okay. Now what is frequency? Can somebody tell me what is frequency? Hamza? What is frequency?
Mu.
Number
One
of
mu.
cycles. Numbers of cycle per unit time. Correct? Okay. Number of cycles per unit time. For example, if you have a complete circle kind of thing and you just point somewhere red dot here and you start counting how many cycles am I circling this. So this is one cycle and it was so fast that it is moving at least 5 cycles per second. How many cycles? 5 cycles per second. So this is 5-second inverse. Okay, so number of cycles per second. Now in waves, what will happen? What is one cycle? One cycle in a wave will be, now see here, this is one complete cycle. Then another cycle will become, this is one complete cycle. Okay, so how many these type of cycles can a wave travel in one unit of time? Generally that unit of time is second. Okay, so the number of cycles per unit time, or we can also write per unit second. So obviously if this is per second, the unit will be second inverse, and there is another name for second inverse which is hertz. Hz we write it, but it is hertz. Okay, hertz. Now the relationship between the wavelength and the frequency is what? The wavelength and the frequency is, if we multiply the wavelength of any wave and the frequency of any electromagnetic wave, this will be equal to what? C. What is C? C is the speed of light. Also we can say that we have the distance, that is lambda, and we have wavelength, which is mu. Lambda is in meter, mu is in second inverse. This is also the unit of speed, and obviously this is also equal to speed of light, or the speed of wavelength, speed of wave. And these are electromagnetic waves. They all have same speed, and this speed is equal to 3 into 10 to the power 8 meter per second. Okay, so there is a lot to digest here. So what I will suggest, Rehab, is to just see this point. Can you remember this much? C is equal to lambda into nu. Yes, we have.
Yes, sir.
Okay, fine. So write only this point. C is equal to lambda into nu. Done?
Yes, sir.
Okay, fine. So let me clear this. Now you will also attempt this question, okay? And what is the value of C, Rehab? Rehab, what is the value of C? You have not written? Write this. C is equal to 3 into 10 to the power 8 meter per second. Got it?
Yes, sir.
Okay. Now tell me what is the value of C?
Wavelength into frequency.
And what is the value? What is the value of C? It is equal to how much? C is equal to the number 3 into 10 to the power 8 meter per second. It is a constant. C, it is a constant that is for light. Okay. Okay, Rehab. Is she there or not?
Yes.
Wavelength of, okay, wavelength of violet light is equal to 400 nanometers. Okay. And the wavelength of, let us say, red light is equal to 750 nanometer. Okay, you have to calculate the frequency for both. Chaliye, start calculating, then we will move to next concepts.
Sir, do we have to use the same formula again? I mean, C is equals to.
Same formula.
Sir, we have to
Yeah,
convert,
the
right?
same thing. No new formula.
Nanometer.
Nanometers, yes, you have to convert. Otherwise, you will get. You have to convert. Nanometers, you have to convert. So you want the conversion factor for nanometer?
Yes, sir.
Okay. So 1 meter is equal to 10 to the power 9 nanometers. So that's why we can say 1 nanometer is equal to how much? 10 to the power minus 9 meter. If you see your NCERT book, na, at the end of the NCERT there are appendix. Okay, in those appendix there are SI unit and conversions. Everything is given there. So I would, I mean, whenever you are in my class, I mean, you are free to check those SI units and conversion factors. Just for violet, for red. I got one of the answer. Okay, frequency for violet, you are saying to the second inverse, right?
Oh, sorry, I forgot to add the minus one.
Okay. second inverse, and you are saying 75 into 14. And for red, you are saying 4 into 10 to the power 14. Can you please recheck the violet one? Can you recheck the violet one? Okay, did anyone else get the answer? What happened? Hamza, Heba, Salman, and Rehab? You can calculate this, right? Yes, Hamza?
Yeah, sir, doing almost done.
Acha, acha, okay, fine. Correct. Now it is correct, Khalid. Now a better way to answer it, Khalid, okay, it would be whatever the previous answer you gave now, the power of 10, just keep it that, and what you can do is add a decimal point between those two digits. So your first answer that you have given, है ना, that is of 2 digit, just insert a decimal point there and keep that power of 10 to whatever the power of 10 you have kept. Got it, Khalid?
Sir, I didn't get it.
Acha, okay, fine. I just wanted to not see those numbers because others are calculating. When I write the answer, you will get it what I was saying. Okay.
Oh, okay, sir.
Okay, I'm waiting for one answer from someone and then I can start doing the calculation. Yes, Rihab, are you stuck or something? Yes, Rihab. Rihab is silent. Rihab, you are on mute.
Yes, sir.
You are stuck? Oh, wow. Yes, Rihab, correct. Rihab is all fancy. She has also figured out how to give exponents. You are using a mobile, Rihab? Or you are on laptop? I don't know whether it makes any difference. Rihab is busy in doing solving the question.
I'm using phone.
You're using phone. Okay. No, Hiba, that is not right. I've done some mistake, calculation mistake, and in powers, you have done some calculation mistake in powers, Hiba. That is why I always say what? First of all, you will get all the answer in second inverse. Here also you will get all the answer in second inverse. The next thing that you will do is eliminate these powers. So it will be 3 by 400 into 10 to the power. How much? 10 to the power, this 9 will come above and it will become positive. Okay. This minus 9 is there now. So if I say 1 upon 10 to the power minus 1, what does this mean? This means 1 upon 1 by 10. So this is equal to 10. Okay. So this minus 9, it will come above and it will become plus 9. So it will be equal to how much? 8 plus 9 is 17. Okay. Here also this will be 3 upon 750 into 10 to the power 17. Okay, guys. Now Hiba and Hamza, I'm waiting for your answers here. This will be equal to how much? This will be equal to 7.5 into 10 to the power minus 3 into 10 to the power 17 second inverse. So this will be equal to how much? 7.5 into 10 to the power 14 second inverse. Now this will be equal to how much? 4 into 10 to the power minus 3 into 10 to the power 17 second inverse. So we can write this as 4 into 10 to the power 14 second inverse. Okay, so can I move on? Yes, Hamza.
Yeah,
Yes,
sir.
Hamza. What
No, sir.
happened? Why did?
Sir, I was
What was?
sending, but I didn't had the option of powers, so I couldn't send. Like because of
Then
the
you should
powers,
have
I
said,
was.
"No, sir, I am done."
Yeah, but sir, what about powers? I couldn't send the powers, right?
Ask Rehab. Rehab, tell them na. How did you add powers and all?
Sir,
Rehab will teach.
I'm using from laptop, so
Ah,
it's not.
laptop you're using. Okay, fine, fine, fine. So laptop you cannot. In Androids, I guess I don't know. In phones, you have that option. If you long presses, then you can get it in power, right?
Yes, sir.
Yes, sir.
Acha, I
No,
mean, whom am I teaching about phones? Okay,
even
fine.
on laptop it's possible.
Even in laptop, it is possible. Yeah, teach us. Who is this? Salman?
Yeah.
Tell us.
There is calculator and then you can choose standard or scientific calculator and stuff. Already on Windows 10.
Arey yaar, they are saying on chat. How to send powers on chat?
Oh, shoot. Who knows?
Chat, there is no option na, in keyboard directly. Okay, fine. Now we know all about wavelengths. Okay, now we know all about wavelengths. Now, yesterday I showed those who were present a video in which there were different atomic spectra. Okay. Now Rehab is here. So should I show this again or should I explain it? What happens? Let me ask Rehab. Rehab, have you ever done that experiment in which you pass light across a prism? White light? Yes. Have you ever done that?
Yes, I guess.
Okay, yes, you guess. Okay, fine. So, what colors did you get when the white light crossed the prism? Acha, you don't know. Rainbow color, na? Right? When the light,
Yes.
rainbow color. Okay, so rainbow is consisting of WebGO. Remember it like this: WebGO. Violet, indigo, blue, green, yellow, orange, red. Okay. Now you also know the wavelengths here, so you can start from wavelength which is 400. This is 400 nanometer, and what is red? Red is how much? 750 nanometer, right? Violet is how much? 400 nanometer, and red is 750 nanometer. So this is your WebGO. Now there was one case in which we got light, but less light was from the hydrogen lamp. Which lamp? Hydrogen lamp. Okay. Now when we got this hydrogen lamp, and in that hydrogen lamp there were only few visible spectral lines. Okay, there were only, and we have got that prism. Now from this prism we got three colors, only three distinct colors. Okay, so we got here how many? Seven colors. Now what were those colors? I have to show you that, otherwise you won't understand. So let us go to that video, that spectrum, but I will not. Okay, just I will ask Rehab. Okay, Rehab, so please you keep yourself on, keep your mic on.
Okay,
Okay,
sir.
can you see that? Now this is white light. Okay, this is continuous light. This is from a simple lamp, the white light that we have. And what you can see is that there are, the pattern of rainbow is there on both of the sides, right?
Yes,
Can you
sir.
see that? Okay.
Yes.
Now observe here. Now this is hydrogen lamp. Okay. Now this hydrogen lamp is also emitting light, correct? Right?
Yes.
So in the center is the lamp. Okay. Yeah. Wait a second.
Yes, sir.
Yeah, okay, fine. You know this. Okay. And what spectrum do you see? You see only three distinct lights, correct?
Yes.
Light, there is one deep blue, there is one light blue, and there is red. Correct? Now we want to
Yes.
find the reason about this. Okay, so that is why we were studying about the waves. Okay, about the waves. Now, since you know there that if red light is emitted, now since you know that this hydrogen lamp is made up of three lights, as the white light is made up of how many colors? Seven colors. This hydrogen light is made up of only three colors. Okay, and those colors involve red, blue, and uh, deep blue or indigo, whatever colors. Now I can write 2 points. First point is that white light consists of seven colors. Okay, that means all the visible colors. But if we say the hydrogen light has only three colors. Okay, what are those three colors? There is one red, there is one blue, and there is one now indigo and violet between that. So I am just let us write violet only. Okay, since we know its wavelength. So that means in that hydrogen light there will be something which is emitting a wave which is of 750 nanometer. Is that right? Does everyone understand? In that hydrogen light, this hydrogen light, there are some waves which are being emitted. There are some waves which are being emitted, and these waves are red. Why? Because they are of 750 nanometer wavelength. Does everyone agree with this? Yes? No?
Yes,
No?
sir.
Achha, please say yes, sir. Then what about Khalid? Yes, Khalid, did you understand? Salman is giving thumbs up. Okay. So I guess Salman understands. Khalid, is Khalid not present? Khalid, you are on mute. Okay, fine. I guess Khalid is not audible. So, what about Rehab? Rehab, do you understand this point? If we
Yes, sir.
have, okay. अच्छा प्लीज अगर नहीं आएगा तो बोल दीजिएगा नहीं आया ठीक है ना now
G.
and also there are some other for example there are some blue lights and there is some deep blue light okay so let us say this deep blue light has 400 nanometer wavelength okay now please be and there is specific wavelength here there is a specific wavelength here okay these two are what they are having specific wavelengths that means whatever is in the hydrogen it is not emitting continuous spectrum it is emitting line spectrum okay it is emitting what line spectrum now that is the point that we want to discuss now that is the point that we want to discuss now there was one scientist his name was Rydberg okay now Rydberg formulated a kind of relationship and he said that whatever we are seeing now we can write that in a formula and we can write that formula as lambda is equal to he said that lambda was proportional to n square lambda is proportional to n square on n square minus 4 okay on n square minus 4 now what is lambda here lambda is equal to the wavelength n is equal to 3 4 etc okay 3 4 etc now if you put here is proportional to n is equal to let us put 3 so 3 will be equal to 3 square oh sorry not 6 square 3 square upon 3 square minus 4 which is equal to how much which is equal to 6 not 6 9 divided by 5 okay so just remember this number here 9 divided by 5 so this again we can write lambda n square is equal to how much let us write 4 so 16 16 minus 4 which will be equal to 12 so 12 we can write as how much we can write this as 8 by how much 6 this can be again written as 4 by 3 okay So 9 by 5 and 4 by 3. Now there is some constant which can be added, multiplied into this, and we can get either 750 or 400, either 750 by or 400. Okay. So can you think of any number which can be multiplied and we get 750? And that number should be constant here. So what we are saying is 9 by 5x is equal to 4 by. No, this cannot be same, no? Okay, no, this cannot be same. There is some other number that we have to find. A Rydberg's constant. I have not taught Rydberg's constant. Okay, but we can say that we are line spectrum. Okay, so we are just here to line spectrum. Okay. Now then Planck came and Planck told that, see, when we are putting that discharge tube into electricity, what is happening? Electrons are coming in, they are breaking this hydrogen, and this hydrogen is broken into H plus and electron negative. Now this H plus is getting into higher energies. Okay, because this is electron is very much excited and it is very fast. It is getting this hydrogen into excited energy, and this higher energy they get dropped from higher energy. Okay, so whenever something is dropped from higher energy to lower energy, for example from E2 to E1, from higher to lower, so whenever there is a drop in energy, what will happen? So energy should be conserved. So if they are dropping energy, they will also emit some energy. Okay, they will emit some energy. Okay, they will emit some energy in the form of electromagnetic waves, and those electromagnetic waves are formed, and we see the red lights, and some electromagnetic waves we see the blue light, and in some electromagnetic waves we see the indigo light or the violet light. Okay, so this is the concept that they are having some kind of energy. They are having some kind of energy. So it means that the wavelength and the mu, the properties of wave, they should be associated with. They should be associated with energy. Okay, so lambda and wavelength, all the waves, the electromagnetic waves, they should have some kind of energy. So Planck formulated a formula which is known as, now you have to write Planck's quantum theory. We will read the details of Planck's quantum theory. Planck's quantum theory. Okay, Salman is showing how to write superscripts. Okay, Planck's quantum theory. There are several points for Planck's quantum theory. The first point is that energy associated with, please write this with me, associated with each radiation. Radiant energy. It's called what? It is called radiant energy. Now, second point is that the energy emitted or absorbed, the energy emitted or absorbed, the energy, right, is, the energy is emitted or absorbed discontinuously in the form of small packets of energy. The small packets of energy, what are these called? The small packets of energy called quanta. They are called what? They are called quanta. This small packet of energy is always in whole number. Always in whole number. Okay. So basically, he was describing the somebody else in the chat. Yes, I called your name. I figured out that you are not present. Okay. So he was describing regarding a hot body. Whenever you heat something, if you have seen something which is heated like iron or some other things, they get hot and they start emitting radiations. Okay. So there is some hot body and it is emitting some kind of energies, right? So if you are near something which is very hot, you can feel that heat, right? So how you are feeling that heat? It is emitting some kind of electromagnetic radiation, and those electromagnetic radiation, they are having some energy, and these energy are in the form of small packets. So this is one quanta. This is one quanta. That means small packet of energy. Okay, this is discontinuously. It is not emitting like this. Okay, this was his theory. That is why, and he said that is why we are seeing some kind of light only. We are seeing some kind of light. Otherwise, see here. See here, what we were saying. We were saying only red, blue, and violet. Okay, so when something is heated, and when we draw the atomic spectra, when we present that light through a prism, we get distinct wavelengths and not all the wave geos. That means it is emitting some specific wavelength of waves or radiations. Okay, now the next thing is that how are these associated with wavelength and frequency? The next point that he said was the energy of radiation. The energy of radiation is directly proportional to. Okay, now I will ask one of you. Okay, I'm drawing two waves, and you will tell me which do you think has more energy. Okay, tell me the case A or case B. Let me ask everyone. Just tell me. I mean, I'm not asking any accurate answer. What is your feeling? So this is the length here is same. Okay, the length here and here. Or let us say this is 1 second. This is also 1 second. So in 1 second it has traveled this much and it has traveled this much. Let us start with Hamza. Hamza, what do you think? Which has more energy, A or B?
Sir, B.
Okay, B. So Hamza is with B. What about Hiba?
Sir, B.
What about Khalid?
Sir, B.
Okay. What about Rihab?
B.
Salman?
B. Major.
Okay, fine. तो मतलब आप लोगों को तो Nobel Prize मिलना चाहिए. You have got the right answer. So as you know that this here we have the wavelength is high, but the frequency is low. Correct? Because in 1 second it is just completing one wavelength or one cycle. Now, if you see here, the wavelength is small, lambda is small, but the frequency is high. And you said that the frequency is high, and you have said that energy is also high. Okay. So let me erase this part now. You have correctly answered it. So congratulations to you. है ना? ऐसे करके क्लास बैठे बैठे अपने घर में ऐसे यस celebrate कर लो. The energy of radiation is directly proportional to what should I write? The frequency, right? To the frequency of that radiation. Okay. So what did they do now? They said that energy is directly proportional to mu. Okay, fine. Then energy will be equal to some constant. Okay, some constant, and then into mu. Now they did some experiment. They found the okay. Now we can say that. Wait a second. Is equal to some constant into mu. So the constant It will be equal to what? E upon nu, right? So they did some experiments and they calculated the value of this constant, and this constant was known as H. And can you guess on whose name was this constant named? किसका नाम दिया गया होगा? This would be named after,
Planck.
yeah,
Planck's
correct, Planck's,
constant.
yeah, Planck's constant. Have you seen Stranger Things?
Yes, sir.
Yes, sir.
I don't know which season, but in that, what was that kid's name? Curly hair, short kid with some very creepy looking teeth.
11.
No, she didn't have hair, curly hair.
Yeah,
Sir.
but I don't remember his name.
What was his name? Dunda? No, no, no. Was there some character by the name D?
Long time since that. I don't remember anything.
Don't remember anything. Okay, now I am stuck. Okay, I can call my sister. She would remember his name. Maybe that guy who went for 2 months somewhere, then he came back. He has a cat. He used to wear cap.
The guy who broke the thing with him, that thing.
The guy who broke the thing.
Broke the
Dustin. Dustin.
Dustin, yeah, Dustin. So Dustin called one of his friend, right, at one point, and he asked about some constant. It was Planck's constant. Do you remember that police guy? He has to enter some code, and that code was Planck's constant. So he telephoned that girl, and then she asked to sing her something.
Yes.
So he was asking Planck's constant. Okay. So we can now write this as what? We can write E is equal to H nu. Now we can also relate from here. C is equal to lambda into nu. So we can write nu is equal to how much? C upon lambda. So we can also write E is equal to HC. Oops. HC lambda. Okay. So now we have also got the equation for energy and the relationship of energy between frequency or wavelength. Write this down. Okay, we have to give the Planck's constant also now. So I'm writing somewhere the Planck's constant. So H is equal to how much? 6.626 into 10 to the power minus 34. The unit will be what? Joule second inverse, right? So H is equal to what? Energy. This is what in joules. Nu is in second inverse, correct? Energy is in joules, and nu is in second inverse. Write this thing down. Planck's quantum theory.
Sir, C is the constant, right?
C is the same C that we have seen earlier. It is 3 into 10 to the power 8.
Speed of light.
Speed of light, meter per second, speed of light. Because we are talking about electromagnetic radiation till now, all the electromagnetic radiation and speed, light is also one of those electromagnetic radiation, and the speed is what? 3 to 10 to the power 8 meter per second. Let me know if you are done.
Yes, sir. Done.
Yes, sir, done.
What about Rehab and Khalid? Khalid, okay, Rehab is also done.
Done, sir.
Okay. So now I will give you a bit of formulas here. Okay. So just see, energy is equal to H into C, H into nu, sorry, H into nu, or we can also write energy is equal to H into C upon lambda. But this energy, what we have written here now, this energy is for one photon. If you have one photon or one wave here, then you will write this particular formula. For example, if you have 10 of those, so this is for one wave or one photon. If you have 10 photons, then what you will write? So the total energy will be equal to E into the number of photons into Hc upon lambda, or you will write E is equal to number of photons into H into nu. Is that clear? So you will write here for one photon, and this will be for n for multiple photon. So we will do a few questions here. I will do the first one, don't worry. And after that, I will give you a few more questions. Then you can start that. Please keep writing here, okay? Please keep writing. The question is, let us say there is a photon of having wavelength of photon of wavelength 31 nanometer is emitted. Calculate its energy. Okay, calculate its energy. So which formula will we use? Hamza, which formula will we use? The red one or the blue one? I mean, the blue box or the red box?
Red, sir.
Red box, right? Solution, it is easy. We have here what? Energy is equal to H is 6.626 into 10 to the power how much? 10 to the power?
Minus 34.
Correct. Minus 34 joule per second into 3 into 10 to the power 8 meter per second, and we will divide this whole thing by 31 into nano is 10 to the power minus 9 meters. So first of all, what we will do in calculations, what do we do? The first thing, how do we start the calculation? We eliminate the
Units.
units. Very good. So see, here's it is second inverse, and here it is. Did I do something wrong here? Joule. Okay, so this is joule second, not second inverse. H nu, na? H into nu. This will be okay. Yeah. So this is second inverse here. Joule second. Yeah. Sorry. This is joule second. Please correct it. This is joule second, because this is energy is equal to, sorry, H is equal to how much? H is equal to energy upon nu. Energy is in joule upon second inverse. So say the second inverse will come and become joule second. This is joule second here. So I have to raise this also, no? Joule second. Now this will be second, and second inverse will cancel out each other. This meter and this meter will cancel out each other. Whatever the answer you will be getting, it will be in joules. So okay, now let me calculate. Okay, let me calculate. I will not give you to calculate because you will take so much time. 6.626 into 3 upon 31. Then what remains here is 10 to the power minus 34 into 10 to the power 8 into 10 to the power 9. This minus 9 will come above and it will become 9. So we can write again here 6, that is energy is equal to 6.626 into 3 divided by 31 into 10 to the power minus 34 into 10 to the power 17. So it will be equal to 6.626 into 3 divided by 31 into 10 to the power minus 17 joules. Now you can please calculate Hamza, if you are done, please let me know you are done, okay? If you cannot write that. Yes, Khalid, I guess that is right. Yes, okay, Rihab, that is fine. Let me know when you are back, okay?
Yes, sir, I'm done.
Okay, you are done. So can you please only tell me, send me in chat the answer for this much. Ignore the power. Salman has also got, okay, Salman is right. Salman is right, correct. Yeah, correct. Okay, now let me just write the answer because most of you have given 0.641 into 10 to the power minus 70 joule. You can write this as 6.41 into 10 to the power minus 18 joule. Okay, fine. I will ask each and every one of you. Okay, Hamza, you tell me, you are okay with this transformation, right? From minus 17 to minus 18. You don't have any doubt here in
No,
exponents?
sir. No, sir.
Okay, Hiba.
No, sir.
Okay, Khalid.
Yes, sir.
Do you have any doubt as I have converted 0.641 to 6.41 and 10 to the power minus 17 to 10 to the power minus 18? Do you have any doubt here in these two
No,
steps?
sir.
Okay. What about Salman? Any doubt in
No,
this
sir.
step? No. Okay, very good. Because ना कभी कभी क्या होता है, if you were in school na, and you were having offline classes, you would have known a few students in 11th standard. They have the simple doubts regarding these type of conversions also. Okay, and that hampers their learning too much. Right. Now you will do those questions. Okay. Now the question will be same. Calculate the energy of 1 mole of photon of wavelength 31 nanometer. Okay. Now Salman will tell me what formula do we have to use, the red box or the blue box. 1 mole. We have 1 mole of photons. Yes, Salman. A red box or blue box? Are Hamza, you tell me.
Sir, blue box.
Blue box, na? And what will be the value of this NP, number of photons? What will you put in there? Yes, Hamza.
The value of 1 mole.
Yeah, what is the value of 1 mole? You don't remember? Okay, Salman got disconnected. Yes, Hamza, what is the value of 1 mole in numbers?
In numbers, yes, I do.
See your notebook. See your notebook fast, okay? Don't worry. This is not examination now, so you can see your notebook. अच्छा, Khalid
Number
knows.
of particles by Avogadro's number.
Arre, it is a number, na? Arre, 1 dozen is how much? 1 dozen is how much?
12 bananas.
So 1 mole is how much?
6.02 0222 into 10 to the
Ah,
power.
correct. Ah, Avogadro's number. Now you are speaking right thing. 6.022 into 10 to the power 23. I hope you all have understood how to do these type of problems. Correct? Please calculate this now. So you have this answer, right? HC upon lambda. You just have to multiply now. You can take the answer from here. Okay, because it is the same wavelength. You just have to multiply the Avogadro's number. Now, while you write the question, I'm writing another question here. Okay, so did anyone get this answer? I've got one answer. Let me see. Okay, Khalid. What was the previous answer? 6.41 into 10 to the power minus 18. I think we have done some mistake, Khalid. Can you please recheck it? Six point 41 into 10 to the power. We get 5 here. Yes, now it is correct. Now it is correct. Don't try. Okay. If you know what is 1 watt, if you remember from your 10th standard what is 1 watt, then you can try this question. Otherwise, don't try this question now. Did anyone else get the answer? Please send me the answer. No one got the answer? Yes, Hamza. You just have to multiply this. Why you are taking so much time? Hamza, Heba. Okay, you have multiplied this and you have got 119. Hamza, you have done some mistake. 6.022 into 6.41. It will not be 119.
Sir, there is C as well. Into 3, it will be into 3, right?
What?
It's C. C is also there.
Array. So we have already calculated this na hc by lambda here. C. What
Yes,
did
sir.
you put here? H. Did you put? See, all of these things we have calculated it already. This was also 31 nanometer, na? This was the same wave. The same photon, we have just put 1 mole of it. So I told you, take the answer from here. You don't have to multiply C or H, because whatever the value of Hc upon lambda, it is this much. We have already calculated. Yes, Salman. Yes, Hiba got it right. Okay, so this is what, how much? This will be, you have written 38, but it will be more better to write 3.8 into 10 to the power 6 joules. Okay, 3.8 into 10 to the power 6 joules. Okay. Now, please, if you have not done, please write it fast, the answer. And now listen to the second question here. Now, if somebody remembers what is 1 watt, what is 1 watt? What is watt? Energy per unit time, right? What is watt? Energy per unit time. And what is 1 watt? 1 watt means 1 joule per second. Okay, what is 1 watt? 1 joule per second. But the bulb is emitting how much light? The bulb is emitting 25 watt. So energy emitted is equal to how much? 25 watt per second. This is equal to how much? 25 joules per second. They have asked how many photons are emitted by the bulb in 1 second. So we have the energy emitted in 1 second. We have to just find the photons. So we will use this formula. E is equal to number of photons H C upon lambda. So energy is how much? In 1 second, 25 joules. What is number of photons? We have to find it out. Into H. What is H? 6.626 into 10 to the power minus 34 joule second. What is C? C is nothing but 3 into 10 to the power 8 meter per second
That's
divided by,
minus 34.
oh yeah, I hope I said minus 34, no? But I wrote minus 3.
Yes, sir.
62 into 10 to the power minus 9 meters. Got this? So now let me use the next column here, next page. So we have 25 joules is equal to number of photons into 6.626 into 10 to the power minus 34 joule second into 3 into 10 to the power 8 meter per second. This whole thing is divided by 62 into 10 to the power minus 9 meters. Now this meters will cancel out. The second inverse and the second will cancel out. This joule from this side and this joule from this side will cancel out. Now as you can see, we have cancelled out all of the units and we will get a number, a pure number. So yes, our unit is also right, that the answer will be unitless. Now number of photons we can write is equal to, we have to put this here, 25 into 62 into 10 to the power minus 9. Okay, now the numerators are done. Let me draw a line here. Then we have, this will be in denominator, 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8. This will be equal to 25 into 62 divided by 6.626 into 3 into 10 to the power minus 9 into 10 to the power plus 34 into 10 to the power minus 8. So this is 25 into 62 upon 6.626 into 3 into 10 to the power 17. Okay, now you have to calculate this. Please calculate this and tell me what is the answer. You can take this as 6.6. Okay, don't be so much concise. Don't need to be so much accurate. You can take this as 6.6. Okay, we have one answer. Yes, Hamza, that is correct. It is correct. Approximately, it is correct. If you use the calculator, it is approximately equal to 77.9. Acha, Khalid has also answered. Yeah, Khalid has also answered. Yeah, both of you are very near. Okay, I mean because you have used 6.6, that is why. Otherwise, the answer would be 7.7 into 7.7.9 into 10 to the power 17 photons per second. Okay, guys. So you can do these type of questions. You can do these type of questions, right?
Yes, sir.
Okay, fine. So there is one question in which you have bulb is of, let us say, 100 watt. Okay, and the wavelength is equal to 400 nanometer. Okay, bulb is of 100 watts, wavelength is of 400 nanometer. Calculate number of photons per second. Okay, Rehab. Guys, you have written this question. Okay, not Rehab,
sir.
Hamza, Hiba, Khalid,
Yes, sir.
Salman. Okay. Hiba, where did you leave? Sorry, Rehab, where did you leave? I forgot, where did you leave? You left here?
Yes, sir.
Okay. Start copying. Let me also explain. Achha, we have learned till here, na, E is equal to h nu. So this E is equal to h nu is if we have only one photon, or if we have only one wave for which we are calculating the energy. But imagine there are for this one wave, there are 20 waves, or for example, there are 100 waves of this kind. Then we have to multiply 100 into the energy of one wave. So what we have a new formula in which we have just added this NP. What is this NP? Number of photons or the number of waves that is having a particular kind of wavelength or frequency or energy. We just multiply hc by lambda and reformulated this into NP into h nu. So this will be for one photon. This will be for multiple photons. Okay. So write this if you have not written. And if you're done, please let me know. Others, okay, fine. You cannot mute me now. Please concentrate on solving that question of 100-watt bulb and 400 nanometers. Okay. Okay. Have you written this, Rehab? Tell me first.
Yes, sir.
Okay. Let us come here directly to this question. Okay. This question here. A 25-watt bulb emits radiation having wavelength 62 nanometers. You understand this much? That there is a bulb which is emitting how many? A wavelength, radiation of wavelength 62 nanometers. Calculate the number of photons emitted by the bulb in 1 second. So they are saying it is 25-watt bulb. So what is 1 watt? 1 watt is equal to 1 joule per second. This is 10th class knowledge. In 10th class, we have learned about watts, right? Yes, we have. You have electricity chapter now. So 1 watt is equal to 1 joule per second. So the energy emitted, we can say that 25 watt. Okay, now 25 watt is the energy. So the energy emitted will be 25 joules per second. Is that right?
Yes, sir.
So now we will use this formula. Energy is equal to number of photons into Hc, because there is one bulb. So one bulb cannot emit only one photon. It will emit multiple photons. So Np into Hc upon lambda. Correct? And we have to calculate the Np here, the number of photons that is emitted by 1 second. We have the energy emitted by in 1 second. We have to calculate the number of photons. We now substitute the values here. H is equal to 6.626 into 10 to the power minus 34 joule second into 10 into 10 to 3 into 10 to the power 8 meter per second divided by 62, and 1 nano. See, 1 nanometer is equal to 10 to the power minus 9 meters. Okay. So in the back of your NCERT in appendix, if you see the SI unit and conversions, you will find this nanometer also. So we have converted this 62 nanometers into meters. So this is 62 into 10 to the power minus 9 meters. Now what do? We go to this slide and we simplify this equation. So the first thing that we did is we eliminated the units. So this joule from this side and this joule from this side can be eliminated. The seconds can be eliminated by this second. This meters can be eliminated by this minute. Sorry, this meter can be eliminated by this meter. Number of photons, we have got this side, and now we have number of photons is equal to 25, because this was 25. No, sorry, no, we have not got this side. We have got this whole thing here and the numerator in the denominator. Linear equation in one variable, you have to just calculate this one variable here. So 25 into 62 into 10 to the power minus 9. Then you can simplify this equation further down, and we got the answer 77.9 into 10 to the power 17 photons per second. Okay. So what I will ask you is to write this question only. 25 watt. Because if you understand this, the previous question were trailer for this question. Okay.
Okay, sir.
These are easy questions. You just have to be very particular with your calculations. If the calculations are not precise, you will get it wrong. Did anyone get the answer for 100-watt bulb? Okay, if you are having some difficulty in powers now, so let us say here we got 3 into 10 to the power 6 joules now. So you write like this: 3.8 into 6. If you have difficulty, okay, 3.8 into 6. Then I will read this as 3.8 into 10 to the power 6. If you have difficulty in writing the subscripts or the powers. Also, you have one more classmate now by the name of Umar. Yes, Hamza. You have any classmate? Umar? Abdullah, I guess.
Umar Abdullah, yes, sir.
He may also join, I guess. Are you guys friends or just know each other?
So we just know each other, not very great friends. We're classmates.
So you're just classmates, okay. How many students? You have 50 or 40 students now? How many students?
In 11th,
Yeah, in 11th, your own section, not the whole batch.
around 40,
Around 40. Okay.
42
And you
maybe.
are 42. Oh, and you are studying in this school since when? Since childhood?
Since 5th standard.
Since 5th standard, okay. So you must be having many friends, no?
No, sir. Actually, I left my school in 6th standard for HIFs. No, 7th standard.
You have completed HIFs?
Yes, sir.
Arey, mashallah. In how many days did you took?
Not days, sir. 1.5 year.
1.5 years is days only. You will say 500 days or 600 days, no? 500 days approximately.
Yes, sir.
1.5 year is, mashallah, yaar, 1.5 year is commendable. Commendable means appreciable. So you have memorized all that rules of tajweed also?
Yes, sir. Not precisely, but somewhat of it.
Somewhat of it. Okay, I
Like,
have cousins. I have two cousins here. They are also memorizing, but I don't know. In 1.5 year, if I tell their father now that I have a student who has memorized the Quran in 1.5 years, they will be scolding. He will be scolding his sons. देखो तुम लोग कर ही नहीं पा रहे हो बताओ इतना दिन से तुम लोग को लगाए हुए हैं
no, sir.
but I will let you.
It depends. Like, if the child is like intelligent or smart, they can do it very fast. Like one boy was there, he did it in 7 months.
Huh?
Yes, in 7 months. Even we were very surprised.
My 7 months is much, but they'll protect them and whatever they have memorized. I know in Palestine there is a madrasa. They have this scheme in which in 2 months, uh, yeah, in 2 months the kids memorize there in 2 months, but not the whole Quran. But see, for admission they have to have memorized, I guess, the Juz Amma, and then they start memorizing from Juz Amma. So, for example, till 27 or 28 paras, they memorize in 2 months, and then they are graduated because the rest 1.5 para, whatever is remaining, they can memorize later on also. But it is very hectic. It is very hectic. It is very famous. If you look in the web now, you will get many interviews. So, how many pages did you memorize daily? You
Sir,
had that?
no, sir. There was a schedule. Like, first month we have to do half pages, then increase half of every month till 4 pages.
Okay, till 4 pages. Okay, so Muhammad is joining here. Okay, but so I will end this class now because Muhammad is also joining. Okay, so have you got the answer for this problem? Assalamu alaikum, Muhammad. Umar. Umar, are you? Wait a second. Umar, are you here for sorry, first chapter, class 11?
Yes, I am here first.
You were with me yesterday also?
No,
No.
no.
So there will be two Umars, I guess. Where are you from, by the way?
I am from Saudi Arabia.
Okay. Indian International School, Riyadh.
Not, not that school name is Al Alia.
So you're not from that school. Okay, which school?
Al Alia. International Indian School.
Acha, Al Alia International School. Okay. And you're originally from?
Originally from India.
Yeah, where in India?
Aligarh.
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 Okay. So you are born and brought up in Riyadh, or what is the scene?
I'm in Riyadh.
Which are born and brought up in Riyadh. Ah, yes, yes. I live in India. Salman is asking, you live in India, right? Yes, I live in India. I don't know Al Alia School. I just say, okay, fine, Al Alia School. There will be, for example, now I know there is one school. There are two schools in Riyadh: Al Alia School, International School, and there is one Indian International School. So the answer here you will get the number of photons. Just wait a second, okay, Omar.
Yeah, okay, sir.
This is chapter 2. Okay, so will be equal to, we will have the H into, see here, what do we have here? Number of photons is equal to 25 into 62 into 9. Okay. This would do something mistake here. Number of photons is equal to this much. Hc by lambda. Okay. The bulb is emitting 100 watts now. So this will be equal to Hc upon lambda. So number of photons will be equal to lambda into energy divided by H into C. Correct? So lambda is how much? Lambda is 400 into 10 to the power minus 9 meters into what is energy? The energy is 100 joules per second. So this is 100 joules. So will be divided by H is 6.626 into 10 to the power minus 34 joule second into 3 into 10 to the power minus 8 meter second inverse. So let us cancel these things out. Second inverse, joule here, meter here, meter here. Okay, so we have got a unitless number. We need that unitless number. So 400 into 100 divided by 6.626 into 3 into 10 to the power minus 9 into 10 to the power 34 into 10 to the power 8. Now we have to calculate this. Whatever we will be getting will be in 10 to the power plus 17. 10 to the power plus 17, right? Now we have 400. We can even do 400 and 100 into powers of 10, but I'm just leaving it here. So you will get this as 2012.2. So you can write this as 2.01 into 10 to the power 20 photons. Okay. So I guess Hamza, you got this answer, no? 20.20. Okay. Right. So please copy this if you have not calculated. We will do some more questions also. We will start with photoelectric effect. Okay. So photoelectric effect, from there also you will get a few questions. Photoelectric effect. This is it for now. Have you guys copied?
Yes, sir.
No, sir.
Okay. Salman is done. What about Rehab? Rehab, did you get to copy?
Yes, sir.
Okay. Now, but is it Maghrib in between when I teach?
Yes, sir. When you
Yes,
start
sir.
after that, just after 10 minutes.
Just after 10 minutes, it is Maghrib.
Yes,
Yes,
sir.
sir.
So Maghrib is a bit. We don't have much time in Maghrib, no?
Yes.
So
Yes, sir. Just one and
let
a
me
half
ask
hours.
Richard, sir, okay, and we will do something about it. And the time will be decreasing now, right?
Yes, sir.
Yes.
Okay, so for okay, fine. Then it will be decreasing. So it will be decreasing. Then at one point of time, you will be. Will you have any Maghrib before the class is starting? It starts at 6:30, na? Or 6 o'clock. It starts at 6 o'clock. Do you have Maghrib before 6 also? In
No.
before 6, you don't have Maghrib, na?
Not
No.
now, sir. When like the time will decrease, then
The time will decrease, but I mean, in winters you will have before 6, na?
Yes.
Yes, sir.
Okay, fine. Let me talk to Nishkar sir if we can do something about the timing. Okay, if somebody can suggest now about the timing, if you have any earlier timings that you want the classes or something, or some other day. But I guess
Sir,
you all are booked.
4 to 6.
Yeah, all days are booked, no? You have
Like
classes
sir,
all.
now it like in Bahrain, it's like 10 minutes before the class start, 5 or 3 minutes before. So it's
Then it will be a problem for the Bahrain people.
soon they will also come back. So, anyways,
Okay, fine. So if you are done, then